So I have the honor to introducing one of the founding members of NGDI, Dr. Robert Hancock. I don't think everyone in this room needs a major introduction for Bob. Bob's a world leader in immunology and microbiology. His impressive bio is on page 8. What Bob is going to speak to today is really about NGDI, a little bit about what we're trying to do here, our vision, our mission, and our strategy moving forward. And Bob, it's all yours.
So thank you. So far, we've had a lot of people, very impressive people, talking about what they've done, what non-governmental organisations and governments and industry can do. What I'd like to do is talk about what we as average Joe university researchers can do about the inequities of poverty and neglected diseases. And this is an issue that has been brought home in many different individual examples, but because I guess most people who've talked so far are not microbiologists like myself, they haven't shown the family photos. So you can see along the bottom here a series of family photos of the parasite, Plasmodium falciparum, malaria parasite, that is basically introduced into human beings, causes infections that basically penetrate into blood cells, but the net response is this little child lying there with this very severe malaria disease. And then just one other major developing country disease to talk about is tuberculosis that currently is present in latent stage in more than a third of the world's population, causing 1.7 million deaths. And it's related to organisms that are more classically called neglected global diseases, such as leprosy and Buruli ulcer. But I would like to argue that if 1.7 million people die every year of this disease, and all of them live in a developing country, this has to be considered a neglected disease. So another thing is that these diseases don't exist in isolation. You talk about, we want to cure TB, but in fact TB basically is dramatically associated with HIV infection. It causes an increased risk of development of active TB, which comes from latency through to causing the active disease. And then the big wild card is that microbes are actually pretty cunning. They're not smart because they don't have brains, but they're cunning in an evolutionary sense. And therefore, you've seen this emergence of resistance to all of the therapies, all of the frontline therapies that we have produced in our society, and most of the second-line therapies now too. And while this doesn't usually exist in the same strain, we have seen the emergence of first multi-drug resistant TB, and more recently we're seeing an epidemic of extremely drug resistance TB where therapy almost always fails. There have also been, despite massive efforts and despite really some fantastic worldwide initiatives, no really new tuberculosis drugs in the last 30 years. So there's definitely huge need here. So I just want to define neglected global tropical diseases. So it turns out that usually people talk about neglected diseases because they persist in the poorest and most marginalised communities, and they've been largely eliminated elsewhere, and therefore they're often forgotten, although of course not in this audience. On the right-hand side there, you see the 15 accepted most neglected diseases, and the red ones are actually ones we work on here at UBC. You can read the list if you like. When you look at total funding, most of the R&D funding goes into the big three, which is HIV, AIDS, malaria and tuberculosis. Relatively little funding goes into these other diseases. And where solutions exist, and there is actually a really nice solution for many of these diseases that's encapsulated in the Rapid Impact Package that costs really a trivial proportion of the amount it costs to treat these other big three diseases, then you can see that despite that, we're seeing billions of people affected. Now, I would argue, in fact, that many diseases are essentially neglected because there are few drugs, effective drugs, and the delivery of those few effective drugs is economically, politically and logistically challenging. So this is not something that you can solve in a lab bench. It's not something that a social scientist can solve by talking about it. It's not something that can just be developed. It's something that requires an extremely integrated approach. I would point out that we talked about these big threes, but only Alan Saul started to talk about the fact that more people die of diarrhea than all of these other big diseases and the neglected diseases, although diarrhea again is associated with a worse etiology when a neglected disease is present, and the same for respiratory diseases. Now, worldwide, we actually have an epidemic, a pandemic of resistance, a situation where even in our society, as you can see from the top right-hand chart there, we're seeing a massive increase of multi-drug resistant organisms for which there are few solutions. The solutions that we have generally cost $1,000 or so a course of antibiotics. This is just absolutely unfeasible for use in a developing country. At the same time, in our own society, we have a dry pipeline that has been attributed to many things, from the loss of scientists who are actually interested in developing novel antibiotics, through to the sense of depression in large pharma, through to pharmacoeconomic reasons, through to the difficulty of getting anything through regulatory approval. We also have problems in that a new disease has emerged every year for the last 35 years, and some of these are big deals like HIV, and some of them fizzed out a little bit like swine flu or SARS virus, but nevertheless these are problems. It's actually usually easier, for example, in the US, to sell bioterrorism that, to my knowledge, killed like 7 people in the last decade, than it is to sell an issue where 7 people die every minute. So there's a massive void in public policy, and I think that this void is one that desperately needs to be filled. And if nothing else, you guys should go out there and start to talk to politicians about these real issues. We also have a changing demographics that affects people throughout the world. We have a generally aging population. We move around the place, so diseases can easily be imported or exported. We have changes in climate. We have more people that have survived through a later age in our society, so they're immunocompromised. We have issues around animal health, etc., etc. And there's this process which Alan Saul started to talk about, which is drug discovery and development. So this is what's involved. We as researchers have traditionally worked in that academic discovery phase, the grey bar there. And then there's an industry discovery phase that covers a series of trials to test various stages of development of the drug. And so if we started off with 10,000 drugs in the discovery phase, on average, one drug would survive through to phase 3, and on average, about a fifth of that drug would make it through regulatory approval. So we have a huge situation. And when you amortize the drug discovery process, all the money in pharma that's done for research and development, divided by the number of drugs that were produced, which was 26 drugs last year from the that got through FDA approval, it's $1 billion per drug, taking into account failures. And I suspect we're not doing all that much better in global diseases at this stage. And furthermore, there's this gap that Alan also talked about that his new institute is trying to fill, which is the development gap. There is no smooth transition between academic discovery and industry discovery. So how can we help the poorest of the poor share in the things that we discover? So we obviously need new mechanisms for encouraging and funding expensive research and development for neglected diseases. And I guess we're extremely pleased to see Peter Singer's initiative, and I believe he's talking to CIHR about expanding that initiative also. We've got to creatively protect early discoveries, and we owe a huge debt of thanks for the work of the Universities Allied for Essential Medicines in trying to encourage us to do the right thing. And we have to think about delivery, because the really big picture here is the bottom right-hand corner. That is a hospital, right? That's a hospital. There's no taps that you can see. There's no beds. There's no carpets. There's no paint on the walls. There are windows. That's nice. So there's a little bit of light. There's one IV drip to which they've basically hooked up every patient. That's what developing country medicine looks like. Okay, so we've decided to create this initiative. We is a large number of people that are encapsulated in that collage. And I'm the guy standing on the microscope slide, so you can see I'm the least of the lot. So this is what we're trying to do. We're trying to integrate the various activities that are involved in bringing drugs from actual discovery through to the delivery in those in need. To do this, we think, three components. We need to have intervention research that involves the discovery and development of all of the good stuff. We need to have delivery systems that have a concentration on health, social, economic policy. And we need that little yellow arrow interconnecting them, because you cannot discover or develop a drug without knowing your clients, and you can't really know what your clients need unless you know what the potential solutions to their needs are. And then we also need to interconnect this with knowledge translation, because that's what we do at universities. And I already told you this is a problem that is being neglected because it's not really that well understood. And encapsulated in this, we need to have partnerships. And I'm sorry to have stolen this lovely little banner from UAEM. This is Joseph before and after HIV medicines to show you what you can do. So I'm going to just tell you a series of things that we're engaged in, that we're going to encapsulate in this NGDI umbrella. So Kish, who is our fearless leader, so he's the big boss in the neglect. Actually, no, sorry, Jocelyn is the big boss, and she allows Kish to stand up and talk, which he's very good at, by the way. So Kish has been basically addressing a really practical need, taking the traditional drug amphotericin B and figuring out how to provide it in a way that it will be more acceptable delivery system for people in developing countries. So he's developed a oral amphotericin B formulation. It works well against leishmania in animal models. That's what all those red bars are there, basically. And it addresses a massive need. So it addresses both the marketplace and the science at the same time. We have a very active group that lead a Centre for TB Research at the University of British Columbia. They have found several really quite novel targets. These targets address new ideas like blocking virulence, like affecting the latent stage, like inhibiting resistance development. We're lucky enough at UBC not lucky enough, we managed to get the funding to build one of the largest level 3 animal facilities in Canada, and I think a very large one in worldwide scale. It's called Finder. We have lots and lots of new ideas, and this group, I think, is going to really help to feed novel products into the process. But this group so far is working in isolation from the clients, and I think that we really need to also bridge that gap too. The Grand Challenges in Global Health Program were very kind to fund the research that we are doing in these immunomodulatory peptides. We have peptides that in a single dose, given either before or after infection, in other words, prophylactically or therapeutically, can cure Staph aureus infections. That's a nice developed country disease that, funnily enough, is also very critical in developing countries. You can see by luminescently tagging Citrobacter. Citrobacter is a mouse equivalent of intrapathogenic E. coli that kills 1 million kids every year. And you can see that a single dose of drug is able to make the luminescence tag Citrobacter completely disappear from mice 7 days later. This same peptide basically also works against cerebral malaria, where we can demonstrate that multiple dosing in a cerebral malaria model where the mice all die between day 6 and 7 is able to protect a sufficient number of those mice, about 70% of them. And this peptide also has, interestingly enough, wound healing properties and is also anti-inflammatory and works in sterile inflammatory diseases. So that's a very, very interesting type of product, and we're just actually going into preclinicals with that. It also protects against tuberculosis, E. coli, salmonella, MRSA, VRE. It's the wonder drug. You only need one dose and you're protected from life against everything. I'm just joking. We did, however, realise that in order to drive this technology, we also need to basically have a commercial arm going. So Brett Finlay and I spun off a company. It's completed phase 1 clinical trials. But all of these peptides have been developed independently for the Grand Challenges program and therefore are freely available without costs to people in developing countries. Another technology that we've developed together with the individuals at the Vaccine and Infectious Diseases Organisation in Saskatoon as part of the Grand Challenges program is overcoming the roadblock of multiple dosing. So most vaccines require 3 doses. Most vaccination sites look something like this one on the Ivory Coast. It's kind of like an open shack if you're really lucky. If you're not so lucky, it's a tree or something in the middle, and people have to walk to get to there. So giving them 1 dose of vaccine is not so bad. Giving them multiple doses can be a big challenge. And so we were challenged with trying to create single-dose formulations. And you can see from the little red thing there, when we use our vaccine formulation that contains 3 different components, with a single dose, we're able to give very high titers against pertussis toxoid. Pertussis is a disease that kills 500,000 or 600,000 kids every year. And we're able to maintain high titers for 80 weeks. We get, for those who technically understand vaccines, mixed Th1, Th2 responses. They're protective and it works better than the current vaccine Quadracel, at least in animal models. It works in pigs, cattle and mice. And it also works in neonates and it works mucosally, so you can have the hope of actually introducing it by nasal spray or under the tongue or something like that. So once you have ideas, you want to translate them. And I told you about that development gap. And we've built an organisation here at the University of British Columbia, but actually now spreading to the rest of the world. We're going to take over the world eventually, called the Centre for Drug Research and Development. And the Centre for Drug Research and Development is an organisation that is like a virtual pharmaceutical company with all of the stages of drug development, including target validation, drug screening, medicinal chemistry, drug delivery, pharmacology and toxicology, and a new biologics division that basically allows you to move drugs through that early development process to where you can demonstrate that they have efficacy that's realistic for animal models. So the whole CDRD infrastructure and the expertise that really comes from hiring all those individuals who were part of the build-up of the biotech industry in British Columbia, it mimics the drug development process. And the idea is to just smooth that transition from discovery through to clinical use. The way this CDR does it is it uses its core assets to fill the development and commercialisation gaps. Obviously, for developing countries, there's no commercialisation, but at least there's a development gap. And it does this by having the appropriate people, which have expertise from target validation to medicinal chemistry through to preclinical animal models. We have state-of-the-art equipment, including high-throughput screening and advanced medicinal chemistry capabilities. And we have now 3 locations in different centres. And we focus on targeted areas of unmet medical need, and one of the big areas is immunology and infection. We've also built at UBC an impressive advanced structural biology program. And this structural biology program has as its major target trying to combat infections using the tools of structural biology. So we're able to use all of the big machines that we have here at UBC to start to ask very complicated questions in developing countries. So we're not just all about science. We also cover the area of health systems research. So here's a centre that has been built up at UBC, the Centre for International Child Health. Charles Larson is the director, and Charles is part of the steering committee of NGDI. It's based on the idea that zinc deficiency is common in Africa, and that zinc is basically making zinc deficiency is increasing the susceptibility to diarrhoea. So one way of treating diarrhoea would be to treat this basic underlying zinc deficiency. And then by doing that, we can shorten the course of episodes of diarrhoea and prevent future episodes. And Charles has some programs that are already underway in Western Kenya and rural Bangladesh that deal with implementation research, I would say, or health systems type of research. We have a massive wealth of social, ethical, economic and political research. I would say that the one issue or the one thing that we're trying to do is to link those to the actual science that's done at UBC. So we deal with all of these particular areas, and we deal with the areas that you may not even have thought impact on global diseases such as macro and microeconomics. But the whole idea is that we believe this is required to inform our research and development on drugs and other interventions. So I'll just give you one example. It's by Jerry Spiegel. I don't know where his name went. There it is. There we go. So, and Jerry's basically studying capacity building and scale up to develop, to control dengue in Ecuador. And basically he's establishing the appropriate protocols for determining whether interventions actually work, which is of course a very good idea, and information systems for determining feasibility. Lastly, NGDI is an initiative at an educational institution. So we're very interested in education. And one initiative that has come out of a group of undergraduate and graduate students at UBC is called the Accessible Science Initiative. And their idea is to promote science education and biotechnology in low and middle income countries to try to develop the capacity to receive these new technologies that are coming along the line. So there's been a Colombian pilot project that just finished last month. It dealt with 1,000 students and 100 teachers and basically provided educational opportunities, an attempt to increase awareness both of public, local issues and also of the potential solutions that are possible in other countries, and particularly to promote collaborations amongst neglected diseases research groups. And then finally, you did hear that UBC is one of the most enlightened universities with respect to global access. We already in 2007 developed principles about trying to ensure that global access would happen. And I'm a living example of the practicality of it. So UBC reserved 4 of our patents with more than 50,000 of the peptides that I talked about just a while ago for the exclusive use of Grand Challenges projects. And these have to be provided free of charge to individuals in developing countries. One of these we've already optioned to a US company, and they understand that there's this global access prerogative, and it's not been a barrier to us out-licensing that technology. We're studying IP, though, also at the research level. So Rebecca Goulding is basically trying to understand the feasibility of alternative strategies to IP protection, and there may be some other strategies that will work better, especially for products that are exclusively for developing countries. So what can we do about the inequities of poverty and neglected diseases? Well, I would say that the first thing you guys can do is go out there and start to talk about it, to let people know that this problem exists. If you haven't had many graphic examples of this in the last few days, you've been probably sleeping through the entire process. So advocate, educate your peers, and get involved. There are both student and now a campus-wide research organisation that provide you with the opportunity to participate. Become involved in NGDI. We're always willing to take a few volunteers, right? Absolutely. We're always willing to take some more people. The other thing is that you may have problems that you're studying diseases of the rich. I mean, I did for most of my career study diseases of the rich. But it's easy once you start to talk to people to find that there are opportunities outside of your own narrow research area. So collaborate to expand your own research. And then finally, I think it's a good idea. And as opportunities come up like the Grand Challenges program, I'm hoping that you'll actually initiate an entirely new area of neglected diseases research and just get involved generally. So all of these are ways that you can become involved. We think NGDI UBC is going to make an impact we're here to help you, and we really hope that you will get involved with us. Thank you very much for your attention.
We could probably have hundreds of questions, and we're a little bit short on time, so we'll take 2 questions for Bob. Peter.
Well, actually, a compliment. It's amazing what you all are doing, and what I like best about it is how you're bringing young people in and combining the hard sciences, the social sciences, etc. It's a great example. My question for you is, as other university communities around the country do this, it's one thing to network within a city or within a university. Hard enough to do. Fantastic that you're doing it. It's another thing to network other efforts that are also happening in other centers. How do you see that happening across Canada so people can learn from you, you can learn from them, and we have a network? It's happening a lot in the United States, the Consortium of Universities on Global Health, but I see it happening less in Canada, and would welcome your thoughts on that.
So a really useful example is through UAIM, which a number of us have been involved in advising for quite a while. So UAIM basically, really, the most active chapter was here at UBC. They did most of the development work in Canada to allow us to convince universities to change their intellectual property policies. And that basically then spread to many other chapters who could point to a positive example. So I think one opportunity is leading by example. The second thing is that I've of course been emphasizing UBC's strength, but virtually everybody that I talked about, virtually all of the groups, all of the centres have collaborators both in the developed world, which includes Canada, and developing countries. And so I see by us becoming a healthy organisation and by inculcating our ideas into the whole milieu, we can also bring along these other groups who we are collaborating with already, and maybe get these general ideas to work with them too.
Peter, if I can add, and you were there when we were at the global health discussions at McGill, and you know, I was a fish out of water. I was the only basic scientist in that room among social scientists and public health people as well, and the great scholarly work in science that was on the social side. And they're all going, who the heck is this guy? But what was really, really exciting about that interaction with Tim Brewer and his global health group at McGill is that we became friends. And so I've learned about the McGill group. They're learning about UBC. We were at Toronto, which was organized by UAM, and yesterday Rachel gave a very passionate talk about that. I met you in Toronto. And so, we're starting to collaborate and talk together, from Toronto. That's how we're going to get it together. I think NGDI right now is trying to take house internally. We need to get our house in order, get our team together, which is starting to happen. And then once that happens, then we can start to move forward. I mean, sometimes if you try to expand too fast or try to collaborate without getting your house in order, then it doesn't lead to success. And we're very pragmatic here. We don't consider this successful if we don't make outcome differences in the developing world. It's that simple. It is that simple. We don't see changes in what we're trying to do. I was struck by the comment one young woman made about the illiteracy issue. That is a huge issue. All right? I grew up in a country where that was an issue. My father, if he was alive today, would say, Kish, don't do brain drain. Okay? Don't take the best people from that country and then poach them for here. Take them, educate them, send them back. Get them to educate their own people. So I think that Canadians, we will do that. But I think, and what's happening also, Peter, is that the other schools are also developing. Tim Brewer told me the McGill School is only now getting things together. So I think that this is going to coalesce, but I think we just have to mature. Okay?
Thank you both.
We're willing to sell franchises.
Yeah. McDonald's, we are. One last question. Now, we did this on purpose because we're not trying to be an infomercial, ladies and gentlemen.
Yes,
we are maybe. we want you to understand what we're trying to do, because this is a tent. We purposely did not call ourselves a center, all right? Or whatever. We said initiative because we're an umbrella. We're here to facilitate you to help your research move forward. That's the point here. Okay, and that's why we wanted to make the thing. Denis, you can have the last word.
No, just maybe to come back to one of my comments yesterday, and Bob, thanks for this presentation, which allows me to get a better grasp of what NGDI is all about. But maybe again, my cautious note, just maybe to repeat it, again, I like repetition once in a while. Don't work in isolation. I mean, what you are setting up is great, but there are also other partners working in, at least in the 3 of the neglected diseases you mentioned, plus TB, plus malaria. And maybe my take-home message is just make sure that we, as a community, are not duplicating efforts. Because in a way, we are all basically fighting for the same resources, for the same amount of money. So to me, it is an important feature. And again, my word from yesterday, quality versus quantity, is something I would like everyone to keep in mind.
So I can't agree more. All I can say is that I didn't talk about linkages, but this whole symposium is there to try to emphasize the fact that we wish to make partnerships with people that we think are important. This is why you guys are here, by the way. So we're looking for appropriate partnerships because we cannot do this in isolation. We're well aware that, but we think we offer certain assets that maybe are not so easy for you to find. And we offer them at a good cost because we're in the university milieu, which is relatively less expensive than it is in, biotech or large pharma. So we think that we do offer you some assets, but the plan is to work entirely in partnership with other individuals. So thank you for that comment.
Thank you very much, Bob.